Let's start, guys. Uh, did you guys got a chance to look into the questions that I posted? Any specific question you want me to do? Did you guys tried any questions or thought about it? Anyone? Can I hear some responses? Yes, no. Or like next create element. Okay, we will do that. The linked list one. Did you try the linked list one? Slow and linked list cycle. Okay, Nirav, can you quickly tell uh, how to do that? Like, can someone just tell me how to do that linked list cycle? Guys, please unmute yourself and speak up. How do you prove it? It's correct.
Sir, for
Nirav,
the okay.
yeah.
So slow fast in that I increased one of the pointers by 2 and the other by 1 only. So for
Okay.
each time the difference got increased by 1. So ultimately they'll come to the same node and they're like the value at the same node, like value at the node would be same if there are the nodes are different, like the value in the nodes are different.
Hmm.
So that way we know when we've got a cycle.
So another part of the question was to find the center middle, the starting of the cycle. Like one question was to find whether cycle exists or not, and the follow-up question was to find the beginning of the cycle. How is it same strategy to find the beginning of the cycle?
So I haven't tried that, but if we know when the nodes are same, we can return that node's address.
Yes, but
So
how will you get the beginning of the cycle?
sir, if we are comparing on the basis of the values, right? Okay, we there will be a
We are
problem.
not comparing basis of the values. We are comparing on the basis of the address, because linked list could be like all values could be 2, but addresses could be different.
Okay, yes. So we can just then return the address.
So address will just give you where they met, right? They can meet anywhere in the cycle.
Sir, I have confusion in this side.
Okay, so let me show my screen. So you have a list, and then there is a cycle, something like this. And then you're saying that you will have 2 pointers, slow pointer and a fast pointer, right? You move slow pointer by 1, so slow will be slow arrow next. and fast pointer by 2. So fast will be fast arrow next, right? And the check is if slow is equal to fast, then there is a cycle, and else if fast is null, because fast will reach n earlier, there is no cycle, right? Pranav, this is what you're saying, or like anyone else who has tried this?
Yes, sir, this is what I'm saying.
So say slow and fast, they meet at position 6, right? And the beginning of cycle is at 3. So how do we determine this 3 as the beginning of the cycle? That was the follow-up question that we have. Like, think about it. Like, if you have not thought about it. Anyone else tried this linked list cycle? Guys, please respond in the chat or somewhere, unmute yourself. Maybe when value repeat, all the values could be same, Karan. All the addresses, only the addresses are different. Jadav, could you tell me your approach? Like, how will you do it? Mike, yes, you can type. Do not have to speak out. Is it the same? Like, do you know how to like get to the beginning of the cycle? Like, we talked about how to find whether a cycle exists or not. The beginning of the cycle, did you solve that as well? How did you do it?
So I had a question. Sir, why will this code not work for detecting the starting of the cycle?
So they can meet at 6, right? This is just saying that slow is equal to fast, then cycle is there. So they can meet over here. It's not necessary they will meet at this beginning of the cycle.
Okay, sure, thanks.
Guys, like, did you guys even try to look at the doc I shared with you? Or like you did not look on and I should just go on doing questions by questions? If that is what you want, we can do that as well. Or you want to discuss specific questions. So I heard that we want to discuss next greater elements. We will definitely do that. But apart from that, do you want me to do specific questions like what is being told by other students, or do you want me to do all the questions that is there in the doc? And I want to know what you did on your front. Like, how do you want me to approach the class? Guys, can I get some responses? Kush, Karan, Saurav, Nirav, Ankit. Like, can anyone tell me like how should be the flow? Like, should I do all the questions, or do you have specific questions in mind? Yes. So Saurav, did you tried anything?
Sir, I tried only the linked list part and I didn't go for the stacks and all because I was also solving other DTPs as well as there was a hackathon yesterday. So
Okay. Rishabh is saying all questions. So Rishabh, did you try any questions, or like you were also busy with the hackathons and things like that? I tried thinking about stack question. I didn't get. Okay, so what we will do is, I think most of you did not got through the questions. I will first discuss this question, linked list cycle, because this is an important question and like you get an idea. After that, I will deal with the next data element, and then as we move on. Okay, as we move on, I will do some harder and harder questions. So what I will do is, let's first start with this one, linked list cycle. Oops. So the question over here is like, did everyone get how to detect linked list cycle, or is there someone who did not got it? Like first, can you guys hack over on the chat if anyone did not got it, or if everyone got it? If everyone got it, I won't repeat the same thing. Okay. So says Sridham, the idea is that you are given a linked list and you want to detect whether a cycle exists or not. So this is an example of linked list with cycle. What you do is you have two pointers, slow pointer and a fast pointer. At each iteration, you move slow by 1 and you move fast by 2. So this is the operation you do, right? And at any given instance, if so slow equals fast, then you say there is a cycle. Else, if there is no cycle, then linked list will be of some form like this. Then fast will reach null earlier. Then you said that there is no cycle, and you stop your iteration over there. So on and so forth. Okay. So two things. One is, how do you prove that this will always detect there is a cycle, right? So we can assume, like, suppose that there is a cycle. Assume that there is a cycle, right? And this is a small part of the entire cycle. And like this is a big cycle over here, right? Since fast is faster, let's assume that fast is over here and slow is over here at any given point, right? At some iteration. In the next iteration, what will happen is fast will move by 2 steps forward and slow will move by 1 step forward, as this is the criteria you have. Given this criteria, both of them in the next iteration will meet at 5. Slow will also come over here and fast will also come over here. And this is part of a bigger cycle. So there's one case over here. Next case that you can look check is like when they are at one distance apart. Let's say slow is over here and fast is over here, right? So in the next iteration, what will happen? Sorry, fast is over here and slow is over here. In the next iteration, what will happen is slow will move to 6, slow goes over here, and fast will move to 5. Fast will come over here. This is the same problem as the above problem. So this is 1A and this is 1B. So 1B gets reduced to 1A in the next iteration, and which we in turn prove that they will eventually meet if they are part of the cycle, right? And since fast is always greater than slow, it will always increase the distance. Like it will always cover up the distance that there is there in between fast and slow. So any arbitrary large distances between fast and slow will be covered, and eventually if they're in part of a cycle, they will always meet. So this is the proof for the first one. Guys, is this clear to everyone? Why they will always meet if they are part of the cycle? Okay. So second is how to detect the beginning of the cycle. So let's first look at the algorithm, what the algorithm is. Let's say that they met at 6, right? So algorithm to detect the beginning of the cycle is you assign like P1 as the head pointer. You take two new pointers, P1 and P2. You assign P1 as the head of the pointer, and you assign P2 as the point of intersection, which is also equal to fast. This is the point of intersection where they both met, and you run a loop and you do P1 arrow next. P1 is equal to P1 arrow next, and you also do P2 is P2 arrow next. So you run a new loop where you increment both the pointers by one value, and if P1 is equal to P2, we say this is the beginning of the cycle. So essentially what you're doing over here is, this is P1, this is P2, and this is P1, right? And you're moving P1 by one step. When you're moving P1 by one step, you will move P2 by one step. Again, you move P1 by one step, you will move P2 by another step, and wherever they meet, you say that that's the beginning of the cycle. Now let's come to some proof like why this algorithm will work. And last class I heard that this is also known as Floyd algorithm when I was teaching DSP2. So let's say this is the cycle, right? Let's say this distance is X. The distance where they meet is Y. This is where they meet, let's say. And this distance is Z. Z. What do you say? Right? So Y plus Z is the length of the entire cycle, and X is the length to the beginning of the cycle, right? Now guys, please work with me. What is the total distance traveled by the slow pointer?
X plus Y.
Sorry, what?
X plus Y. Initially, sir, like when we are trying to find.
Yes. Initially, when we are trying to find the point of intersection, what is the distance traveled by the slow pointer? So it will be X plus
It
Y,
will
right?
be, yes, sir.
But remember, like slow pointer can move also in circles, right? So it will be X. It's not exactly X plus Y. It's like X plus some M1 times the length of the entire circle. Say L is the circumference of the circle, and then Y, right? So it comes over here, slow pointer. It does some iterations, like say M1 loops for the circle, and then it moves to Y. Now this M1 can be 0 as well. So we are not debating about that. If M1 is 0, then it reduces to X plus Y. But generally, this is the distance traveled by the slow pointer, right? Also, what is the total distance traveled by the fast pointer? Can someone answer? Like using this hint only.
It should be twice of this.
Yes. But that won't lead to anywhere. So it will be X plus M2 L plus Y. Is this correct? Like M2 is some other variable.
Yes, sir.
Right? Where M2 is more than M1, we can say that as well. Or not really. Yeah, we could say that. So what's the relation between these two? Guys?
The one
How can you equate these two?
fastest double of the flow.
Yes. So twice of x plus m1l plus y is x plus y, right? Now if you rearrange it, then x plus y becomes m2 minus 2m1 times l, right? Now this we can write some k times l, where k is some non-zero constant, where k is more than zero, non-zero constant, you can say, right? And it's an integer because all of them are integers. So is this part clear to everyone? Okay. So from here, what do you conclude? That x plus y is some multiple of the circumference of the cycle, some multiple of the cycle's length, right? Because it's k times l. Now, let's say you have a pointer over here p1, which is already y distance ahead of the starting of the cycle, and you have another pointer p2 which starts from here. Now when p2 travel x, when p2 will travel x distance, p1 will also travel x distance, right? So when p2 travels x, p1 also travels x distance, right? But p1 is already y distance ahead of the cycle, right? Because that's where we initialized our p1 with. So when p1 travels x distance, it will complete one length of a cycle, because x plus y is should be some multiple of the length of the cycle, right? So we say since p1 is already x y distance ahead, or p1 starts y steps ahead. So this is a symbol for since p1 starts y steps ahead after traveling x distance, or x steps.
Sir, P1 starts y steps ahead of already the starting point of the cycle, right?
Yes.
Okay, sir.
P1 starts y steps ahead of starting point. So after traveling x steps, it will travel some multiple of the cycle. Because x plus y is some k times l, right? So when it travels x, so it also travels x, and we know that after x, p2 will be at the starting of the cycle. So p1 also will be at the starting of the cycle. That's why we say that you do at each step you move both the pointers by one distance, and wherever they meet, that's the beginning of the cycle, right? So you move this by one distance, and you also move this by one distance, and wherever they meet, that's the beginning of the cycle. So is this part clear to everyone? Can the p1 and p2 start at any point, or only start by 2 steps ahead? Sorry, I did not get you, Raghav. P1 will start over here where both of them met. P2 will start at the head of the cycle, head of the linked list. Right? Okay. Any questions regarding the proof? Did everyone get it? Why this is correct?
Yes, sir. Clear.
Clear? Okay. So do you guys want me to code this, or should I move to the stacks and you can code it on your own? What do you want?
I think so. We can code it ourselves.
Okay, good. So what I will do is, I've already coded it in DSP batches, lead code. If you don't get it, then you can look at the code over there, right? Let's move to the next question, which is stack. So let's look at the generic question first. Next data element, as that was demanded. Let me see which problem is. No, not this one. Is this the one? No. So take a look at this question. Question number 503 on lead code. And like instead of circular array, just assume that for now, for simplicity, that there is no circular array, that there is just one array, right? So should I paste this link over here? Or you guys have the link, Google Doc, right? Just use that doc. Yes. So use that doc and go through the question once. So essentially the question is saying that for each element, let's say you have an array 8, 6, 4, 1, 9, 7, 5, 3, 2, 4, 6, right? So this is the question. The question demands like what is the next data element for each of the elements. So for 8, the next data element is 9. For 6 as well, the next data element is 9. For 4 and 1 also, the next data element is 9. For all of them, the next data element is 9. For 9, there is no data element, so you provide -1 over here. For 7, there is no data element, so you provide -1 over here as well. For 5, you see that 6 is the next data element, you output 6 over here. For 3, 4 is the next data element, you output 4 over here. And for 2, you have 4 as the next data element, so you output 4 over here. For 4, then the next data element is 6, so you output 6. For 6, there's no next data element. So when I say next data element, I'm saying next data element to the right. To the right of, when you look right, then what's the next data element? For 6, the next data element is -1. This is none. So you want to output this as the final array. That is the question. So think about it. The time complexity should be order n. Space complexity can be order n. Also, Pranav, like, could you tell me like what you thought? Like, how will you approach? Like, we can discuss that and maybe probably come up with solution from there.
Sir, I could not see how to use a stack. All I could think was we traverse the array for each element.
Okay. So what was the complexity for your question?
Sir, it can be up till n square because we are traversing the array for each element
Okay.
till we find the next greater.
Array is circular, only the maximum element doesn't have the next element, so we can start from the maximum element. We need to do it in 2 loops and maintain the next element by using stack. How do you maintain the next element, Jadav? That's the question. Guys, anyone has any ideas, solutions, suggestions? So this is more of a discussion class. It's not me speaking and you listening, because that won't benefit you unless you think as well. So if you want to come up with some solutions, please do so, and we can refine it over there on top of it. Anyone with any ideas? Like anyone, like order of n squared is pretty trivial, so you can always do order of n squared. Order of n, if you have any ideas, please speak up.
So we can insert elements in the stack one by one. First 8 will go, and we can insert up till the elements are smaller than the previous element. So first 8 will go, then 6, then 4, then 1. If 9 is greater than 1, so we'll pop 1. Now 9 is greater than 4, so we'll pop 4 too. Now similarly it goes on. Answer, we can find the solution like that.
Yes, yes. So Pranav, did you get what he said, Samarth said? Okay, nice. So mostly whenever we use stacks, what we have is stack will always have there's an invariance that stack will always follow, right? And whenever you do questions with stacks, one specific type of questions, you always need to think, or in queues as well, that there is some invariance that the stack will follow, and that should be satisfied across the question while the question is being solved or the question is in progress. So the invariance that we have over here is stack is always it's a monotonic stack. And it is always decreasing. So that is the invariance that the stack has. And using this invariance, we are going to invariance that what is the property of stack that will not change when you loop through the array. What is that specific property? So that specific property is it will always follow the monotonicity, and all the elements in the stack will be in decreasing order. So it's invariant to the problem, like any array you give, it will always follow that particular property. For any questions for any array, if you want to find next element, we will always use this property. Okay. So when I say monotonic stack, then the question comes that you always need to have monotonic stack, right? And why do we need a monotonic stack over here? What's the advantage? We see that if the stack is monotonic, and if the values are always decreasing, and we are looping from left to right, right? So let's say you have a stack. I'm just doing a sideways views, and you're putting values over here. So you put 100 over here, then you put 87 over here, then you put 86 over here, then you put 51, so on and so forth. So the value, if you plot a graph, right, the value is always decreasing like this. Now, if the value is decreasing in the stack, so this is the value, and this is the element index. So if the value is always decreasing, then you definitely know for sure that for this one, this cannot be next to the element. Or similarly, for these two, this cannot be next to the element. For these three, this cannot be next to the element. For none of them, the next element is the greater element, right? So on and so forth. Now let's say a new element comes with a value greater than some specific values, right? Now, since a monotonicity is always maintained in the stack, we know for this is the greater element. If it were a lesser element, we would have pushed it into the stack because we have that the invariance, right? So since that invariance is not being followed, we know for this is the greater element. So we remove this from the stack. For this as well, this is the greater element. So we remove this as well from the stack. For this element, this is the greater element. So we remove this from the stack as well. Let's say the value of this is higher, right? So for this is not the greater element. Let me erase this. So we had to remove all these elements, and then we say we'll remove this as well. Any question? And when this comes, we say, okay, this is value is less, so we will keep this as the value for the index. And for this, we don't know the next greater element. And then we proceed and look at new elements. So the three values that we had over here, for those greater elements were determined. And then we pushed this into the stack. And that's how we continue. Like for, so if we go through this example, we will first, and this is the stack say, we will first push 8, then 6 is less than 8, so we push 6, 4 is less than 6, we push 4, then we again push 1. Now 9 is more than 1, so we say that for 1, next data element is 9, because if 9 was smaller, we would have pushed 9. We remove this one. Now we see 4 is also less than 9, so we say 4, the next data element for 4 is 9. Similarly, we do it for 6 and we do it for 8. When none of the elements are left, we push 9 in the stack. Then we check 7. 7 is less than 9. So we say that next data element for 7 is not determined. For 5 as well, 5 is less than 7. 3 is also less than 5. 2 is less than 3. Now 4 comes. 2 is more than 4. Then we say that for 2, next data element is 4. Then again 3 comes, then we say for 3, next data element is 4. 5 is more than 4, we push 5 over here. And then we, again 6 comes, for C, we say that 4, next data element is 6. We remove this and we push, we again see 5, for 5, next data element is 6. We remove 5 as well. And then we push 6. So ultimately what is left in the stack are values 9, 7 and 6. So these are all decremented value in decreasing order, and for them, the next data element has not been determined. Also, if you check, another invariant will be like stack will only contain those elements for which the next data element is to be determined. So that's the other invariant that is there. And this is like anytime while it is iterating, not at the end, but anytime during any iteration, it will only contain elements for which next data element has not been determined. So this is clear, right? The concept is clear, right? Like how we will use stack. Guys, act, no act. Okay. So can someone tell me what is the complexity? Time complexity and space complexity?
So time complexity is O of n, and space complexity is based on, because we're using 2 stacks, so it is also O of n. So basically both of them are O of n.
We are only using one stack. We're not using 2 stacks.
Oh, sorry. If we're using one, yeah, then still both of the cases are O of n.
Yes. So this is O of n. Why? A simple argument could be every element is pushed into stack at most one time, and it is popped out of the stack at most one time. So we are visiting every element at most twice. So that's why the time complexity is overfed. Space, because we are using stack, at most n elements could be there in the stack, so space is overfed as well. So that completes the proof for time and space complexity, and this is how we do next grid element, right? So before going to the original problem that we have, let's say now the question is to find the next smaller element. How will you do that? How will you do this next smaller element? So the idea is you have to find the element which is the next smaller element to the right of it. So let's take the same example. So for 8, the next smaller element is 6. For 6, the next smaller element is 4. For 4, next smaller element is 1. For 1, there is no next smaller element, so it's -1. For 9, next smaller element is 7. For 7, it's 5. For 5, it's 3. For 3, it's 2. For 2, there is no next small element, so it's -1. For 4, there is no next small element, it's -1. For 6, also it's -1. So this is the final idea that you need to output. How will you do it? So first tell me what will be the invariance for the stack.
The elements present in stack, they would be in a decreasing order.
Decreasing order?
Sorry, increasing order. Yes.
Increasing order?
Sir, let's say, wait.
Like think about it.
Yes, sir. From the top of the stack to the bottom of the stack, they will be in a decreasing order.
Okay, I see. Yes. So when you push, then element should always be greater, right? That's what you're saying.
Yes, sir.
So over here, I said that stack will always be in decreasing order. So I said like from the base of the stack to the top. So like you are saying from top to the base, it should be decreasing. So it's essentially like it's in increasing order from the base to the top. Right? So it's a monotonic stack as well. It's always in increasing order. That's correct. And how do you do it? Like if the value is decreasing, so again you plot the graph, right? This is the index of element, and this is the value, and values are always in an increasing order, and then a new value comes, which is less than these values. Let's say it's less than 2 values, and then all the other 3 values are greater, right? So you know that the next small element for this is this one, and also the next small element for this is this one. So you remove these 2 values and you push this into the stack. The other invariant is the stack will always contain elements for which the next smaller element is to be determined. So that's the other constraint that you have. So I won't go through the dry run. I guess it's pretty obvious. 8, 6 is there, then you pop 8 out and you push in 6. Then 4 is there, then you pop 6 out and you push in 4. 1 is there, you pop 4 out and push in 1. 9 is there, you don't pop 1 out, you push 9. 7 is there, then you pop 9 out, you push 7. 5 is there, you pop 7 out, you push 5. 3 is there, you pop 5 and you push 3. So right now, 1 is the only element, and any other element that comes, you see a small element, so you push in. Then 2 comes, 1 is there, and 2 is greater, so you push in 2 as well, because you are maintaining that invariance, because 2 cannot be the smaller element for 1, so we push 2 as well. Then 4 comes, 4 is also less than 2, then you push 4. 6 comes, 4 is more than 2, and 6 is more than 4, so you push everything. So in the end, this is the stack you have, that's always in increasing order, and for all of them the next smaller element has not been determined, right? A hacky way to do it is you will negate all the values and you apply next data element. So you do -8, -6, -4, -1, -9, -7, and then you can find the next data element from here, like using the same algorithm. But yeah, that's not the, like, that's the hacky way, and I won't recommend that. So is this part clear, how to find the next smaller element? Guys, ACK, no ACK, these two concepts will be very critical, like almost in all the stack problems. These two concepts will come into play. Even in Q problem that we will do, we will always have this concept of maintaining the monotonicity. So if you guys have even slightest bit of doubt, please tell me, I will explain it over here, because in the next, like all the hard questions, they will be cakewalks then after if you get this concept. Okay. So cool. Do we create new stack for numbers we don't have next smaller element? No, we don't create new stack. In the end, whatever element is there in the stack, they don't have next small element. So that is the invariance, right, Jadav? Like increasing order from base to the top, and all the elements for which next small element is to be determined. That's the invariance that we have for the stack. So in the end, whatever is there in the stack, the next small element is not present over there. Okay. Cool. So if everyone gets this part, now the question that is there in lead code for next data element 2, it is that assume that this is the array that you're given A1, A2, A3, so on and so forth, AN. It's a circular array. So after AN, you will go to A1 again. That is the only thing that you have. And now you want to determine the next small element, next data element for all the elements you have, right? So it's more of an implementation, like how do you want to implement the circular array, and it's not the question of next data element. What you can do is you can loop you can loop it for twice. So you can say for I equal to 0, I less than 2 times the size. Let's say size SZ the size of the array, and I plus plus. You do this, and then you say int current index is equal to I modulo size. And then with current index, you can do all the calculation that you have. So you're looping through the array twice, and you're computing current index. So what this will ensure is it loops through the entire array twice. And thus it will get, it's as good as what you're saying is A1, A2 all the way till AN, and again you put A1, A2 all the way till AN. So if you're doing this, and if you're concatenating 2 arrays, you're essentially doing the same thing. So for this element, if the next data element was not AN, it could be for element AI, right? If AI plus 1 through AN, none of them will be greater. So it will check all the elements from A1 to AI minus 1. So that is what we'll do if we concat these 2 arrays. But similar thing can be achieved if you can run twice the size and you do modulo operation. So the space complexity will be lessened. Is this clear to everyone? Any questions, doubts, concerns? Guys, ACK, no ACK? Okay. Okay, so I will just show you how to code the next data element once, because the same thing will be there everywhere. So this is the code I did from DSP2 batch. Just remove this, right? And then we say that we have a stack of ints s, and then we will also create a vector int of answer. So the size will be, let's say, int size is equal to nums dot size, right? So this also will be nums dot s size, and default values will be -1. So it creates a list or a vector, whatever you would like to call. Then you loop through everything. So you say if for I equal to 0, I less than twice the size, and you do I plus plus, and then you say int j is equal to I modulo size. So this is the current index that we have, and then you check for monotonicity. And what is the monotonicity? Always decreasing. That's the monotonicity, right? So you say that while, so you want to check the stack.top, right? If stack.top is less than nums of j, that is what you have, right? So the values are decreasing, and the new value that you encountered is more than the top value of the stack. Then you say the answer for s.top is, so stack will contain all the indices. It contains all the indices. That will be easier. So I would say nums of stack.top. If it contains all the indexes, we say nums.stack.top is less than nums of j. So then we can say answer for stack.top is determined. We say answer for stack.top is nums of j, right? And then we pop it out of stack. That's what we do. And we do it every time until the top element is greater than the current element in consideration. Also, one constraint is stack should not be empty. So we say not stack is empty. And these two things we say, right? And in the end, we will push s.push j. That's what we do. We push the current index in the stack, right? So when everything finishes, stack will contain all the elements for which next data element is not determined. So it will only be one element, and initially by default it was initialized as value -1, so I don't need to check and initialize the value. So I just return the answer. Is the code clear? It's very short code. Okay, it worked fine. So let's go to the next question. Largest rectangle in histogram. So it's problem 84. So go through the question, think about it for 5 minutes, and then we will resume our discussion. I'll be back in 2 minutes. Okay, guys, did you come up with a solution? Any idea? Anyone? Any thoughts? So what are the assumptions that we can make? So say this is the histogram we have. And over here as well, you have some histograms over here. So on and so forth. You have histograms, right? So think of one thing is that when you're saying the largest rectangle, then that rectangle should have some histogram as its full length. So say if I want to determine what is the largest rectangle if I only consider this histogram, right? Or let's say I want to determine what is the largest rectangle if I only consider this histogram as the top element. So 1 minute. Okay, guys, my laptop might disconnect, so I will rejoin if it disconnects. So the largest rectangle, if this is the histogram I consider, then it can extend its boundaries to these two parts only, right? Because after that, this element is smaller and this won't be the part. So the largest rectangle that this histogram will cover is this one, right? Similarly, if you take any other histogram, let's say if you took this histogram, right, the largest rectangle it covers to the left, if you go as left as you can, and you go as right as you can, right? You stop over here. So you say, okay, this is the largest rectangle for histogram that this particular histogram can cover, right? Similarly, if you check for this one, you go as much as right you can. This is smaller, so it can't cover this area. And you go to the left. This is again smaller, so you can't cover this area as well. So this is the largest rectangle that this histogram can cover. This particular histogram can cover this as in. So taking this as in, can you come up with a solution? So essentially for each histogram, what are we trying to compute? Like how, till when can I go to the left? And till when can I go to the right? Can someone answer? Or someone comment?
So till the values are greater than the middle one.
Yes. So until I do not find a value smaller than the current element, I can go to the left or to the right, right? So until the value is greater, I can move to the left, right. If I find a smaller value, I have to stop. Similarly, if I go to left, I can move unless I find a smaller value than myself. Yes. So that's essentially what we're doing. So what is the problem now? Like in terms of stack, the problem that we did, what is we are trying to solve over here? What problem are we trying to solve over here? Next smallest, right? So we are trying to solve the next smallest element, both to the left and to the right. So we are trying to solve what is the next smallest element to the right, what is the next smallest element to the left. So say this is the current index I, right? And IR is the next smallest element to the right, and IL is the next smallest element to the left, right? So the area of the histogram will be IR minus IL, right? Times the height of I, the height which is present for the ith index. And so that we can do for this histogram. Similarly, we can do this for all i's. For all i's, we can compute this, the next small element to the right, next small element to the left. So for all i's, we can compute the histogram height that they can make. Now we have to take the maximum. So we do argmax. We do max over all the values we have. Max for all values of I, we do this. And that's the solution, that's the final solution. So max for all I, we do this. We can remove this one. Right? And what's the complexity? So we know that to compute the next small element to the left is order of n. And this is for all the elements. Also, to compute the next small element to the right is order of n. Similarly, you can reverse the array, and you can do again this. You can apply the same concept. So that is order of n again. So with two traversals, you can compute the next small element in both directions. So the total complexity to find the maximum height will be order of n. Is this clear to everyone? The concept? Any part which is not clear? Guys, ACK, no ACK, unclear? Clear? Explain time complexity वाला. नेक्स्ट स्मॉल एलिमेंट का क्या टाइम कॉम्प्लेक्सिटी है जादव? नेक्स्ट स्मॉल एलिमेंट ऑर्डर ऑफ एन में होगा ना, तो तुम उसको दो बार रिवर्स कर दो. लाइक एक बार टू द राइट ले लो और फिर एरे को रिवर्स करके वापस नेक्स्ट स्मॉल एलिमेंट निकाल लो, तो वो तुमको लेफ्ट का दे देगा. So it's order n for computing the next small element towards the right. The same idea will be used to compute next small element to the left. and then you can do it. Right? So this is done. Any questions? No questions? Nice. So I'm not going to code this. I'll put the solution out. I will recommend you guys to code it on yourself. And so that is done. Let's look at the next question, maximum rectangle. It's question number 85, maximal rectangle. So this is the question. So think about it for 5 minutes and then we can approach to a solution. Sir, we would have to do it for every element, so shouldn't we n square? So next small element, we did it for all the elements, right, Karan? When we compute next small element, we compute it for all the elements. Or when we compute next great element, we compute it for all the elements, right? So computing it for all the elements took order of n if you use stack, right? N square will be like if you do brute force. Right? Okay, so this question. So I'll give you a hint, right? For this question, you need to do prefix sums. And then you also need to apply the histogram idea that we had over here. So assume that every row as a base of a histogram, this row as one base once, and then consider this row as the base of the histogram. You consider this row as the base of the histogram. So when I say base, then like where the histogram starts, what I'm saying. And this row as the base of the histogram. So you do prefix sum and base of the histogram. That's the hint that I have. Like think about it. If anyone has a solution, like you can post it on chat as well. Guys,
So for we start with row 0, and
yeah.
it is like I'm not so sure about the code, but this is kind of modeling of the problem. Like
Mhm.
we start with row 0, we see what is the maximum height of the rectangle which we can get with base at that row.
Yes.
Then we move on to row 1,
Mm-hmm.
and then we do the same thing. We see what is the maximum height of the rectangle which we can get.
Maximum height of the rectangle. Okay, the previous question.
The histogram, like the
Okay.
the
And
col-
how do you compute? How do you get the histogram?
sir, for each index, we will see if the upper index is also 1. So we'll
Mhm.
increase the column height of the histogram.
Okay, yeah, that's the way. Yep, that's correct. And you do it for all possible rows, right? Taking that as the base.
Yes, sir.
Yes. So that's the way. What is the complexity? Can you just think through the complexity once?
the n square.
N squared, yes. Okay, so let's move on. If anyone of you have any other solution, like please share. We will go through the solution once. So now this is maximal rectangle, right? So you have this one, right? 0, 1, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1. Let's say, and 1, 1, 0, 0, 1. So what you do is, at every time you consider this as the base, so you try to form an histogram with this as the base. So histogram will have a height 1, like if every element on top, we will have the count, the height of the histogram will be number of elements that are 1 above that element. So for this, the number of elements 1 above that is 0, like there's only one element, so the height is 1. For this, height is 0. Now for these two, height are 1s again, right? And now this is 0. So this is equivalent to a problem that you need to find the maximum rectangle in a histogram for this question. This is the question that you have. For next height, what you see is again you compute the height. So then how do you compute this? You, for every element, you check how many consecutive ones are there above that element. So for this, there are 2 ones. So over here, the height will be 2 for this histogram, right? These 2 are 0, you don't matter. And then for again these, there are 2 ones. So height again will be 2 over here and 0. So now the question computes like get the maximum rectangle for this histogram. Again for this, you do the same thing, taking this as the base, you compute the heights. So now the height will be 3 for this one. There'll be two one height's length, the 0 height, and another height over here. So thing is to compute, and similarly you do it for this one as well. So I guess over here the height is 4, then height is 2 over here, then there are 0 heights, and then there is a height of 2, right? So it's like solving the same problem 4 times and getting the maximum out of this. So for here, the maximum rectangle that you get is 2. The maximum rectangle that you get over here is area is 3. Maximum rectangle area you get over here is 4. So the answer is 4, which is this rectangle that you have. This is particular rectangle, right? Now, why this is correct? A way to think about it is any rectangle will have something as the base, right? One of the rows will be the base of the rectangle for the answer. And over here we are like exhausting all possible combinations, like taking everyone as the base. We are saying that the maximum rectangle will be from this base. So we are going through all possible combinations. That's why the answer is correct. We are not missing out on things, or we are not considering the cases which is not there. So like for this one, if you take this one, the histogram, this is of height 3, the first one, then 1, then again height 3, then 2, 2, right? So the maximum rectangle for this is 6 over here. So is this clear to everyone, the question? Like once you get, and everything boils down from the next greater element, smaller element. From there we solve histogram, from histogram we solve this question, right? So I guess You got it. Any questions still over here?
Sir, can you please explain that once again? Actually, I got disconnected for a while, so I couldn't get
Which
it.
which part?
Sir, the histogram representation, after that histogram representation part.
This one you got this part?
Yes, sir.
So now I'm saying this, for the optimal solution or for the correct solution, the rectangle that you will have to lie in one of these bases, right? Because it has to have one of the rows as the base of the rectangle. Do you understand that?
Yes, sir.
Yes, and we are going through all possible bases. Like we are going through all possible rows and considering each one as the base. So essentially we are checking, like, if this was the base, what would have been the maximum rectangle? If this was the base, what would have been the maximum rectangle? So on and so forth. So it's not that we are missing out on any cases where the base is not considered. The way we are doing it, we consider all the bases. That's why we will always get the maximum rectangle. Is that part clear?
Yes, sir.
Okay, cool. So maximal rectangle is done. Now daily temperatures, right? Sum of sub-area minimum. So sum of sub-area minimums, its idea is very similar to the histogram one. So just go and do it. I won't do this in the class. The daily range temperature. So guys, my laptop might get disconnected for 5 minutes or 10 minutes. Please bear with me. The daily temperatures for this one. This is also very similar. I won't go through the daily temperatures. Let's go to remove k digits. So can you help us with the code of maximal rectangle? So I would encourage somewhat that you code it on yourself. Like if you can code largest rectangle, you can also code maximal rectangle. So is there any part which you did not got for maximal rectangle? Like which I can explain? Any specific part? It's clear, right? So I would say that just code largest rectangle. Then maximum rectangle, it's one thing that you need to keep in mind is how do you compute the base. So the way you compute the base is you create a one array, like current base, and you append that array. So current base right now is 10100. When you calculate the current base for this one, then you check whether the previous value is 1. If the previous value is 1 and this is also 1, then you add 1. So you add 2. And if the current value is 0, you straight away write 0. Else you add 1, just you add 1. So that's how you compute the current base every time. And you do that. It's not much of a difficult thing to do. So like, do most of you want me to code maximal rectangle or should I move on? Like, what do you guys want? Like, I guess this should be fairly easy. Like, largest rectangle is coding the next small element. If you can code next small element, you can get the largest rectangle as well. Also, maximum rectangle is coding largest rectangle. So I guess this is pretty simple. Okay, cool. So look at this one, remove k digits, right? It's 402, problem number 402. So guys, so there is some issues with my laptop. It will reboot itself in 2 minutes. So I might get disconnected. So I will join from my phone. That happens. Okay, so will this end the recording? Let me just contact someone. So if you are thinking about remove kdages, you can also think about remove duplicate letters. If you guys have time. Any guys? Any hints like any solutions? Any suggestions?
Just starting from the right side,
Uh,
we can remove the next greatest element towards the left.
yes.
Will this like, is this correct? Like, but we are limited by the number of elements we can remove, right?
Yes.
So I'm not sure if this works, but it should be something like this.
Okay. So remove k digits, right? So you have digits D1, D2, D3, so on and n digits, right? And you want to remove k of them so that the final answer is as small as possible. That's the constraint. Now, so what is that? Which digits you want to remove? Essentially, if I want to make values as small as possible, if I traverse from left to right, then largest k digits from the left side. Yes. So if I traverse from the left to right, then I want to remove all the digits which are greater, right? Uh, uh, I want to remove digits in such a way that the final values that I have D1, D2, DK, all the values will be like result in a smaller value, like a smaller, as small digit as possible, right? So I want to remove it from the most significant bits. The the higher the cardinality or higher the order, and if it's a greater value, then we want to remove it. Let's say that I have this one, right? 3, 1, 2, 4, 1, right? Then I would, and there's on for k equal to 1, only one digit I have to remove. So if I remove 4, then the value will be 3, 1, 2, 1. But if I remove 3, value will be 1, 2, 4, 1. So this is always lesser because I'm removing it from the greatest bits, most significant bits. So if depending on the value of k, I would want to remove all the values which are like greater, higher in cardinality. And other thing as well is, let's say you have 2, 3, 1, 2, 4, 1, right? Now, which one will you remove for k equal to 1? For k equal to 1, you won't remove 2 because 3 has a higher cardinality. So you do one ways you have 1, 2, 1, 2, 4, 1, and one is 3, 1, 2, 4, 1. So definitely this is greater than this. So if you encounter a digit which is greater, then you remove that digit because that will further reduce the thing. On the other hand, if you had all the digits like which were less, 2, 1, 1, then you would have removed 2 because this is the most highest cardinality digits in the left hand side or in the most significant bit, right? So we are greedily picking from the most significant place which all digits we should remove in order. So it's essentially finding like you have a stack, or you are finding the next greater element. For every element, you're finding the next greater element. So if all the elements are smaller, then it's fine. But you're finding, what are you doing? If the element is smaller, then you're removing that element, right? So you're finding the next smaller element, not the greater. Sorry, I take back. We are finding the next smaller element. If the element is smaller, then you remove that element, right? So the invariance that we will have is that we need to remove largest k digits from the left side. Could you repeat? Like we need to remove largest k digits from the most significant bits. What, like going from the left to right, when you try to read out, like what is the number, then the most significant bits, most significant like places which should be as small as possible. That is what I'm saying. So invariance that I will have is, it will be monotonically decreasing stack. And it will contain all the digits in the final solution. So let's say you have example 30200, right? And you need to remove k equal to 1. So what do you have? 3 is there, right? And then 0 comes. So I'm getting confused over here. Should it be monotonically increasing or decreasing? I guess it should be monotonically increasing stack, because if it's an increasing stack, that's what we want. Like we want most significant digits to be as small as possible. And since it contains all the digits in the final solution, so it should be monotonically increasing. So yeah, so if 0 comes, then 3 is more than 0, so you remove 3 and you put in 0 over here. Then 2 comes, 2 is more, it's okay. And if k is 0, then since you have removed one element, so you put k as 0. So once the k is 0, then you keep it over here, and you cannot remove any other element. So the final solution will be 200. That's the final solution that you have. Is this part clear to everyone? Like monotonically increasing, because in stack we are maintaining the final solution. So the most significant bits should be as small as possible. So let's work out through an example. Let's see if my Chrome is up. Okay. This the one. This the one. Okay, you can see it now. So let's say the example is 1432219. So let's work through an example once. So it's 1432219, and k is 3. You need to remove 3 digits. So 1 is there. It's okay. You put it in the stack. So there is a stack. 4 is more. Okay, you put 4 as well. 3 comes. So 3 is less than 4. Then we say, okay, 3 is a much more ideal candidate than 4. I will remove 4. So you remove 4, you decrement k, the value of k to 2, and you push in 3 over here. So now 1, 3 is there. 2 comes. We say 2 is much more ideal candidate instead of 3 to take its place. So I remove 3 and I push in 2. So again 2 comes. Again 2 comes. So nothing there. 1 comes, and k is 1 over here. We can remove one element. When 1 comes, we say that okay, 1 is much more ideal candidate than 2. So you remove 2 and you push in 1. So ultimately 1 to 1 comes. Now k is 0. So you cannot move anything. So you push everything in the stack. And that's how you get it. Right? So this is the final value that you have, like the decreasing element, the minimum, remove k digits so that the element is as small as possible. So the idea is remove from the most significant places so that the value is as small as possible. That's the only idea that you have. And that idea then translates to, if you check to the right and if you have a smaller element, then you remove that element. So essentially that is where the stack comes into the play, because you need to find a small element to the right. Is this clear to everyone? Any questions, doubts, concerns? Guys, any questions? Why considering only some elements? What do you mean some elements? I'm considering all the elements, Jadhav. I mean after 1 in stack. No, I'm considering all the elements. 1 is there. After 4 comes 4. Then I push in 4. Then 3 comes. Then 3 is less than 4, right? So I remove 4 and I push in 3. Then 2 comes. Then 2 is less than 3. So I should have this arrow so that you understand. 3 comes and 3 is less than 4, you pop out 4 and you push in 3. Then 2 comes, then 2 is less than 3, then you pop out 3 and you push in 2, so on and so forth. Then over here 1 comes, then you pop out 2 and you push in 1. So this is the same stack, it's not multiple stacks. Any guys, did everyone get it? Can you act, no act? Something that is not clear? We can discuss this if it's not clear. Okay. Nice. So this is done. Do you guys want me to code this? Because it's coding next smaller element. It's the same thing. Guys, what do you want me to do? Move on. Nice. Let's look at this one. Remove duplicate letters. So this is the question, like question number 316. Can you guys think about it?
Sir, we take in the string one by one, and we basically maintain a vector. For every input I take, I'll have to put it to its right position, like lexicographically. So I'll have to keep moving it forward if it is smaller. And if at any point I encounter two same elements, I'll pop one of them.
Can you do a dry run for this one, BC, ABC? Or what are you saying?
So first we push B, then we push in C, because C is greater than B already.
Okay.
Then we push A, so we notice that A is less than C, so we'll swap their position. Then again B will be greater than A, so we'll again swap them. So it will be now A, B, C, and then the next thing we'll take in is B. Now we'll swap B and C. Now B and C, like for new position of this B, the previous element is also same, so we'll pop one B. And the next element which we take is C. So the two elements are same, so we'll pop one C. This will be difficult to implement, I guess. But
so essentially you're saying that will swapping always work? I don't think so. So let's say you do this one, right? CBA, DCB, right? So you won't swap, I guess. CBAC. So let's do a dry run for this one. CBAC, DCBC. This is the string, right? So C is there, it's fine. B is smallest, so you will swap B and C, so BC will be there, right? Then A comes, then you swap this two things, right? So what you do is you do B, A, C. Now A and B is also small, then you do A, B, C. And then again a C is there. So since there are two C's, you remove one and you do D, C, B, C. Right? So it's A, B, C. D is greater, you put D. C is smaller. Then you swap these two. So you do A, B, C, and since there are two C's, you do this. Then you do A, B, C, D. That's what you're doing, right?
Yes, sir.
And then B comes. B is smaller. Then you again swap these two. Ultimately, you're getting A, B, C, D, right? If you are doing smaller.
Yes, sir.
But that's not the question, right? Because the final solution for this will be like, okay, A is here, you put in A, then C are there over here as well. So you put C over here. D is only there in this place, and B is towards the last. You can't put this B because that will be lexicographically datest. So this is the ideal solution that you have, A, C, D, B. But you cannot get A, B, C, D from here. So A, B, C, D is not possible from here. Only possible string is A, C, D, and B, which is the lexicographically smallest string and which contains all the 4 characters. So swapping won't work because you are changing the ordering of string as well. That is something we don't want. So very trivial example, if BA is the input, you will output AB as the final output, but the final output for this will be BA only. It won't be AB. Because this is the lexicographically smallest string and all the characters are unique. So Pranav, that solution won't work. Guys, anyone has any alternate solution? Like, please speak your mind, like what you're thinking. So one thing is clear, right? We want lexicographically smallest string. So can do it in way like sort them in alphabetical, and if we get duplicates, if you sort them in alphabetical order, then you're changing the order of the string, right? Then it's like you're doing all A's all together, then B's together, C together, and D together, right? And then you remove, then it's A, B, C, D, that's it. But that's not what we want, right? So the question is saying that you can remove elements in place, but you cannot change the order of element. And there should be at least one element, like all the elements should be distinct. That's what it is saying. So when you're sorting it, you're changing the ordering of the element. So think of this example only. Sorting will always give you the sorted order. Is this remove k digits from D code? No, this is remove duplicate letters. Number 316, Rishabh. Essentially what we want is, let's say you have a string. Let's say you have a character C1 over here, right? And then there is some characters C2, which is greater than C1, and it's to the left of it, right? Now, the C1, definitely C1, so C2, C1 is lexicographically larger compared to only C1, right? If I take two strings, S1 is this and S2 is this. So C2, C1 is lexicographically larger than C1. Now what we want is I want to remove C2, but at the same time, I want to ensure that at least one instance of C2 is present in the final output. So when can I remove C2? Guys, can you answer this? When can I remove C2 if it is before C1? Guys? So we can remove C2 if it is before C1 only if C2 is present to the right. There is some instance on the right when another C1 occurs after C2. Yes, that is the only time I can remove C2. If there is no instances of C2 to the right, then you cannot remove C1. Then you have to keep it over there. Right. So it's like finding the next. So what did this question reduce to? Like you will have a monotonically, since I want lexicographically largest string, like lexical smallest string. So you will have monotonically increasing stack. That is the constraint. So that it's like all the small elements are pushed to front as possible, but you will only pop this out of stack if a higher value is present to the right of it. So there is some kind of memory storage that you need to do. Like we will have some kind of a map or an array which says that C1 frequency is F1 for C2, frequency is F2 for C3, frequency is number of occurrences, so on and so forth. For Cn, the frequency is Fn. That we do, and then when we come to the current index and we check this and we say C2 is there, and in the stack, let's say in the stack some values over there, C3, C1, C2, C4, and again, like let's say C5 came. We have to traverse twice. Yes, we have to traverse twice. Once we need to compute the frequency for all the elements. That is the pre-processing that you need to do. And next time, let's say C5 comes and C4 is there. Now, if in the original string, there is another instance of C5, there is another instance of C4 after C5, then frequency of C4 is, let's say F4. If it is greater than 0, like greater than 1, not even greater than 0, if it is greater than 1, then we can remove C4. If it is not, then we won't remove C4. If it is 1, then remove C4. You reduce the frequency of 4 by 1 value, and then you push in C5 over here. So stack is monotonically increasing stack which contains the final solution, which is the distinct elements. Is this part clear? So do you guys want me to code it, or like you guys can code it on your own? What do you want? You can do it. Okay. So I just got one response, like everybody agrees to Karan.
So could you please repeat when are we removing C2? Could you please repeat the conditions, the two conditions when are we removing C2?
Okay, so like work with me over here. You had some, let's say, let's take an example. So you have B, C, dot. You have D over here, dot. You have an A over here, dot. And again you have a D over here, right? Now, can I remove this D if A comes?
Yes.
Why can you remove it?
In that way, we'll have like A, since A is smaller, so that will be lexicographically smaller as well as.
But say if this was not there, then could you have removed it?
No.
Right. So the only case you can remove it is when you have another instance of same letter or character that is present after this. You get this part, right?
Yes,
So we have to check. Initially, we have to check for the whole string, right? If there are duplicates.
We have to get the frequency for all the characters, like how many occurrences are there,
Okay.
right? So is this part clear? Like we can remove this only when there's another instance, a greater instance present to a character which is lexicographically smaller than this character. So even if a B was here or C was here, you could have removed D because D is there in the end as well. So you're not changing the ordering of the string because you are taking this value in the end, right? Guys, is this clear to everyone? I'll code this just for the sake of it, so you guys can understand as well. So it's remove duplicate letters. So we will have vector of frequency 256 because it's only lowercase, but it's okay. I'll add 256. And initially frequencies are 0. And then I compute the frequency for all the characters. So I see for auto characters in S, I say frequency of CH is plus plus. You increase the frequency. So you're computing the frequency for all the characters. Now you take a stack char. So one more way to do for doing this is one more thing that you need to keep in mind is that if an array, if character A is present in the stack always, so let's say this was the case, A, C, B, D, and again an A comes, right? So this is already present in the stack. So you just want to continue when this comes. So you just remove this. So you need one more thing, that what all elements are present in stack. So for that, we will use a set. So we say that stack of character S, right? And also we say a set of character, like what all characters are there in stack. So if the same thing comes, like A is over here, and again say B is over here, and again a B comes. So this is already present in the stack. So or let's say C is over here, Y256 ASCII, and C comes, then that's why. So what you do is you say for auto CH in S, what you do is you decrease the frequency of CH. Yeah, you can do it, but everywhere you have to write CH minus A, CH minus A. That's why I just left it. It's not much space, right? And then you check whether this is in if dot find CH is not equal to in stack dot end. If it is not equal, then it means that it is present there in the stack. So you just continue over here because it is present in the stack. And then you check while. Well, what is the constraint over here? Guys,
Sir, if there's a smaller element towards the
So what
right.
is, can you write? So we have ch and you have s dot top. What should I write? Smaller. U element is smaller than the current element on the top of the stack, right? And another thing is frequency for the element to be removed from the stack is more than 0. These are the two constraints, right? So what will you add over here? Guys, so this is ch is less than s dot top, right? If the current element, which is ch, is less than the top element and frequency for the top element is more than 0, right? Then you say in stack dot erase s dot top. That's what you do. You do in stack dot erase s dot top and you do s dot pop. You do these two things together, right? One more thing is the constraint while stack is not empty, that you need to write. So that's the third constraint that you have, right? After that, you push the current character and then you also put it in the set in stack dot insert ch. Now let's say the final answer is there. Then you say while not s dot empty, you say answer is equal to s dot top plus answer and you do s dot pop. Then you return the answer. Any question, concerns? Any part which is not clear? So every time you are getting the element, you are decrementing the frequency because you are removing, like you're counting, discounting that element. And then you say that if it is there in the stack already, then you don't want to add that element again. Else we are taking that as a potential element to be added in the stack. So when will that be a potential element? When it is not in the stack, first case, and then all the elements which are smaller than, which are greater than that element is in the stack. So you remove all those elements as much as you can. Once you remove all those elements as much as you can, you push that element and you also push it in the set. You have attempted to, what? Why is it not working? Sir, why auto ch repeat code example once the in5? Oh, auto, okay. I'll just call this text. Let's first compile this. Okay, so auto is automatically gets what is the type for this. So it's a char. You could have written char over here. I wrote auto, so it does not matter. So say you have a vector of set of int v. Now it's difficult to iterate through vector like all the sets. So I can say auto s, or you say current set in v. So it reduces that. The type for this is set of int. So it's an iterator. Like this is an iterator, and the type of this is set of int. So is this clear? It's just ways to code. right? Okay. So this works. Any questions? So this worked fine. So this question is clear, right? Like how this will do. Okay, so this is it for today. We will have some classes on databases as well, like, and in those classes I will discuss one more question with you guys for queues, and that will be it for stacks, queues, and linked list. Any questions, concerns that you have? Anything which was not clear? What I will do from my side is I will upload all the solutions in the DSP batches link. Try to go through the solutions that we discussed today. And if there is anything you did not understand, like we have a Slack group, you can post it over there or in the WhatsApp group. I prefer Slack because it's very easy to browse through the questions. And we can discuss it over here, like why I did that and why I did this in the final solution. But I would encourage you to try it on your own. Anything else?
So will tomorrow's class be on or like we'll be sticking to the timeline which has been given to us?
Pardon?
Sir, actually yesterday we were supposed to have this class and but yesterday's class was skipped.
Tomorrow's class will be as normal as it can get.
Okay, sir.
So database we will have one more class, so don't worry about that.
Okay, sir.
Karan is saying, why are we maintaining frequency array? Why are we also checking set? So Karan, frequency array is for this one. If there is an element to the right, then you remove this element, right? So there could be a case where this came, you put in D and again an A comes, or again, so let's say D A, D B, D. So for here, element is there towards the right, so you push that element out. Then you put in this, B comes, you also need to check, okay, there's one more element to the right. So you put this out as well, and then D comes, right? So for this, you need a frequency array, right? And in stack is, let's say A, B, C, A is there, right? Now in the stack, A, B, C is there already. These three values are there, and A comes again. So you don't know, right, whether it is there in stack or not, else you will get duplicacies. So we say that if it is already there in stack, you don't consider it at all. You just move on to the next element. That's what we are saying. Is that part clear? Karan, are you there?
Sir, can we discuss time complexity of this?
Time complexity?
Of
So what do you think? Like, we are iterating through once, right? Every element we are checking it only once, and it's getting pushed into the stack once, and it is getting popped out of the stack exactly once. Like, so every element we are doing operations with every element exactly 2 times, maximum 2 times. So time complexity is order of n, right? And maintaining stack, pushing it in a set and things like that you can assume that's order 1 operation, right? Or you could have some set, right? Frequency of 2 so we had this one, right? Frequency of 256. This array, you could have another array in stack which was also of value 256. This could have been a Boolean array, whether it is there in stack or not. So if it is there in stack, you set it to true. You can do this with this Pranav, right? This thing will take order 1. I agree, set won't take order 1, like, but there are ways to optimize that as well. Any other question? Okay, so I will end the meeting for today and we'll see you guys later.